Hello, and thanks again for joining me for my next adventure in automation. If you've been following the series so far, you'll have watched as we prepared the demo lab for action, assessed our approach, then started to dig into our first use case, which was to verify NTP config and operation in a subset of our lab. In the last video, we looked in detail at how we use Postman to query the IP Fabric API in order to extract the data we need to first check and validate configuration and state, then prepare to automate configuration changes. Today, I wanted to take that a little step further and show how we can get that same information using a programming language so we can build some logic around it. Now, I've made some big assumptions here, as I don't want to teach anyone how to suck eggs or go over ground far better covered by people way more qualified than me. So, I'm assuming that number one, we're going to use Python as a programming language. It's the default option for network programming due to the simplicity and clarity of the structure it brings, and in no small part to the fact that there is a huge library of modules, functions and plugins available to build network tooling. There's nothing wrong with other languages, of course, and the concepts will translate. Number two, you have a machine set up ready for script development with a Python interpreter installed on either an IDE, that's an integrated development environment, or just a good programming editor. Perhaps Virtual Studio Code or Notepad++. We won't use the IDE or editor very much in today's video, but it is key to have a good environment for developing and debugging your code. And thirdly, that you have an idea of just how API requests and responses work. But of course, if you've been watching all our videos up to now, you should be up to speed. There are loads of great references to drill down into all these things in more detail that certainly do the topics way more justice than I could here. So I'll put a list of some recommended ones into the description below. I know many networking engineers learning these skills using the materials provided by Cisco's DevNet program, for example, but there are plenty of other free and paid options. Now, last time we built a series of API requests in Postman, and we were able to see the responses returned in the raw JSON format, which, while it's readable, is really built to allow us to work with the data in a structured, programmatic way. As we pointed out briefly, Postman has a very useful feature, which outputs the Python code needed to execute the API request and return values. So, that's where we're going to start digging. As you'll recall, the first thing we need to do is log into the platform. We supply a username and a password, and IP Fabric establishes an API session and returns an access token and a refresh token to us. Let's take a look at the Python code used to make that request. First thing is that we use a number of functions from a standard module called requests. This is our way of interfacing Python with the outside world of RESTful APIs. We assemble requests, execute them, then assign responses to variables to manipulate the data coming from that external system. In this simple authentication case then, we assign the URL variable a value matching the IP Fabric platform API endpoint. We then create the request payload to contain the JSON string representing the username and the password that we wish to pass to the server, and we assign header parameters to a variable that allows us to adjust the format of the output. When we're happy the request is formatted correctly, we make the call to the server, and the response is placed in a Python dictionary, which we can then use to manipulate the data contained in that response. In this case, we simply output the text of the response on the screen. Let's run that through in an interactive Python session so we can see the impact of each step. So you can see here I've opened up that Python interpreter, and what I'm going to do is line by line we'll paste those commands in, and we'll watch as the response builds on the previous step. First thing then was the import request, which is loading that requests module into Python to enable us to run those functions. Now there's no response to that, it just goes ahead and imports those functions. So then we take the URL variable, the payload variable containing a text string representing that JSON with the username and the password in it. The headers variable is actually a JSON, well, it's a Python dictionary, the equivalent of JSON format, and that is a key value pair of content type and application JSON. So basically we're saying we want a JSON response, and then we very simply use the request function from the requests module to go ahead and get some details. And we've got a bit of a problem. What's happened here? Well, if you look closely, you can see there's an SSL certificate verify failed message, and it's flagged up the fact that this is a self-signed certificate on the server. Now, the server is in a lab environment. This is completely valid. We can override that error message by simply including verify equals false parameter at the end of the response request, and you can see here that it basically flags that it's an insecure request, but continues with with providing us with the correct response, and we can check that with the print statement, which shows us we have our access token and our refresh token response as we'd expect. Now, what we can now do is take the information from that response and put it into a variable for us to reuse. So what I'm going to do, I'm going to import another library, this one called JSON, which allows us to process information in JSON format. We're going to load the string in JSON format, and we're going to extract the access token from it. So now if I do a print of token, you'll see I have the content of the access token from the response there. Ready for our next query. Right. So with our inventory API request, we filtered based on the site we were interested in, L1 in our case, using the information that we copied from the web UI. Now, in the Python code snippet, you can see that the URL maps to the API endpoint for inventory, that the payload is a string representing the same JSON data that was copied from the platform, including that filter string. The header data this time also includes the access token from the earlier authentication process. Now, we'll replace this with the token variable from our earlier request. Otherwise, you can see that the form of the request is actually very similar. So let's try running this one. So you can see we still have our token available. We don't need to re-import the requests module because it's already there, but what we do need to do is assign our URL and payload variables, like so. Our headers variable is a little different to last time. As you'll notice, what we're doing is we're assigning here our authorization key, the value of bearer plus the value of the token variable that we've got above, and that allows us to insert that token into the request to prove that we're authenticated. Okay, we carry out our request again and assign the content into the response variable. Again, we get our insecure request warning, but only a warning. And now if we print our response, you can see we have a whole load of data in here, and all this data basically is the inventory data that relates to site L1. You can see in the middle here site name L1, site name L1, and so on. So you can see there where we've pulled that data from, and that it's accurately what we need it to be. Obviously messy output, so let's pretty that up a bit. The JSON library actually gives us a way of doing exactly that. So we can take the data from the response here, we can put it into a variable that we call inventory, and now what we can do is use this use the JSON dump or dump s function in order to display this in a cleaner, neater way, as you can see. So there the structure is much more obvious. You can see a lot more clearly what it is that you're dealing with. So that's a handy one for output. And so you can see the inventory there now we've pulled through from IP Fabric, including all the devices that are in L1. Now, our third example was to pick a request to pick the NTP source configuration and state from each device in our chosen site. So again, we used Postman to show the snippet required, and we can see that we can retrieve the information from the NTP sources table, filtered again here using the site L1 and using the authentication token that we've previously retrieved. Let's run that one through the Python interpreter. Here's our URL and payload again, and you can see payload slightly more complicated again, but still with that filter line embedded in the middle. The headers value, same as before, we incorporate the bearer token directly in there. And again, for our response, our request, we post our URL, same as before, with the headers, with the data payload, and with the verify equals false to make sure that we only get the insecure request warning, but it carries on and completes the job. Now, we can grab the config sources, the NTP sources, out of the JSON, and we can view that by pretty printing it like we did last time, and you can see there that we've got a list of items. Well, it's a dictionary of configuration items. You can see for each one we have a host name, so it's the device that's been configured. We have a source IP address, so that's the actual time source as it's configured, and you can see its current state, that it's reachable. You can see which site it's on, you can see the stratum it's been assigned, you can see the jitter and offset details and parameters that you would see in the table and on the command line for that device. So all of that's managed to be retrieved. Now, what we can do at this stage, because we have this dictionary of, let's have a look and see how many items there are across all of the devices. Here we go. In the meta key value pair at the top, you can see that our count is 20. So we have 20 different configuration items here, some of which will be against the same host name. So for example, L1F1 here has a source of 1.1.1.1 configured, and then it also has a source of 10.0.10.10 configured there. So there's multiple configuration sources there. Now what we can do is we can loop through that dictionary and perhaps print a list of all the devices that have items configured that aren't reachable. Let's give that a go. So we can use a for loop, and we can take right. There's a set of sources. So we'll take for each one of those sources, we'll check and see is that source reachable. And don't forget, same with everything with Python, it needs to be indented. And if it's not reachable, then let's print the host name, let's print the source address, and the fact that it's not reachable. Nice and simple. And there you can see straight away we have 3 sources configured on these devices in L1 that aren't reachable according to the detail there. And if we wanted to just double check, what we could do is do the same, but obviously have display the ones that are reachable. Let's just do that for completeness. And there you can see a number of devices here which have all configured for the source 10.0.10.10, and that is reachable from all of those. So we can see that those are synchronized. Hopefully this has been useful to see just how those API requests could be translated into real Python code to obtain the data that we need to achieve our checks for our use case. Next time, we'll take a look at just how to make those config changes on the devices. Thanks for watching. As usual, useful links and so on will be in the description. Please like, comment and subscribe to the channel and click that notification bell. And I hope that you can join me soon for some more adventures in automation.